we're going to go over trig ratios today. Trigonometry, it comes from two Greek terms, trigon meaning triangle and metron meaning measure. So we're going to be measuring triangles. When we label triangles, the angles are in uppercase and the sides are in lowercase. Notice A matches with the opposite side and angle B matches with their opposite sides. Alright, we're going to go over labeling the sides of each triangle related to theta. Theta just means the angle that is chosen. So we're going to label the hypotenuse, which we're just going to label with a hype. Opposite, we're going to label with OPP, and adjacent, we'll label with ADJ. So if I'm using angle theta in this corner, opposite, if I were to walk to the opposite side of the room, I'd walk straight across, and this would be labeled opposite. Now, if I want adjacent, adjacent means between. So like a wall that is shared between two rooms is an adjacent room. This side is between the two angles. It will be labeled adjacent. And the hypotenuse is across from the 90-degree angle, almost like the 90-degree is an arrow. That is the hypotenuse. Alright, let's label this one. We have our theta. This time, instead of being in the bottom corner, it's up at the top. So here's my given angle. I'm going to label this side. When I walk across the room is the opposite side. The adjacent side is between my two angles, and the hypotenuse is the longest length, which is across from the 90-degree angle. We have the theta. This is our chosen angle. Opposite would be walk across the room, opposite side. The adjacent is between the two angles, and the hypotenuse is across from the 90-degree angle. Alright, this is going to help us find the trig ratios, and we're going to represent them as a fraction. So a saying we can use to remember this is SOHCAHTOA. So SOHCAHTOA. For me, I like to write it a little bit differently. I like to write it as so is O over H. So ka A over H ka toa T O over A. I like to write it this way so that I have so ka toa. That means, so when I look and they ask me for sine of C, sine is represented by the S. Cosine is represented with the C. And tangent is represented with a T. This is how we're going to use it. So for sine of C, I know that sine is equal to O over H. So when I go through and label, I have to use sine of C. That means C is my angle. Based off of my angle, I have the opposite side. I have the adjacent side. And I have the hypotenuse. Now all I have to do are take the numbers that I've labeled and plug them in. O is 24. H is 40. Then we can reduce it. And it can't reduce anymore. So once I've reduced it as much as I can, I'm done. Sine of C is equal to 3 over 5. All right, let's try cosine. Cosine is equal to A over H. I'm using the angle Z, which means O is the opposite side. 24 is the side that's between them, so adjacent. And Y is the hypotenuse. Now I plug them in. A is 24. H is 26. We can reduce that fraction to 12 over 13, and then you can't reduce the 13 anymore because it's prime. So we're done. Tangent. I kind of wrote over it. We're going to write it down here. Tangent is O over A. And we're using angle Z. That means opposite side is 14. Adjacent side is between the angles. And the hypotenuse is across from the 90. So I plug in O, 14, over A, which is 48. And reduce it. And we can't reduce anymore. Alright, problem 4. We have sine of angle C, so we know we're using C. And sine is equal to O over H from SOHCAHTOA. Opposite is across opposite side. Adjacent is between the angles. Hypotenuse is across from the 90. I plug them in. O is 15. H is 17. Can't reduce it, so we leave it. Cosine of Z, angle Z, is equal to SOHCAH A over H. Opposite side, adjacent side, across from the 90 is the hypotenuse. A is 21, the hypotenuse is 29, and can't reduce. tangent, SOHCAHTOA, of angle Z. Opposite is opposite across the room. Hypotenuse is across from the 90, which means the last one has to be the adjacent. O is 27. A is 36. Right.